This is problem 19 from the 2023 AMC 10A. The line segment formed by A12 and B33 is rotated to the line segment formed by A'31 and B'43 about the point PRS. What is the absolute value of R minus S? There are 5 options again. So let's just firstly draw out this coordinate plane system, because right now we're kind of confused about what's going on. So this is the y-axis, and this is the x-axis, this is 0, this is the origin. So we go 1, 2, 3, 1, 2, 3. Okay, so where's 1, 2, where's A? This point is going to be A. What about B? 3, 3, so this is going to be B. Okay, and this is a line segment, so we connect A and B. Okay, what about A prime? 3, 1, so this is A prime. What about B prime? 4, 3, so we need another 4, so this is B prime. And we're going to have to connect these two points again. So we have 2 line segments, and there's this rotation about the point PRS. So we just want to find the point P. So this right now does not look really like a rotation, more like a transformation. So how do we rotate from this to this? Well, notice that. So one thing we should know, no matter what, is that in the rotation, wherever the point of rotation is, let's say it's here, the original points, so A, have to be equidistant. So let's say this is P, have to be equidistant. So AP has to be equal to PA prime. So the corresponding points on the 2 line segments have to be equidistant from the point of rotation. So this means that BP has to be equal to B prime P also. So we need to find such a point. So how do we find a point that makes both BP equal to B prime P and AP equals to A prime P? Well, we need to use our geometry properties. So the perpendicular bisector. So if we connect A prime, like not actually connect, just like a dashed line, and we take the perpendicular bisector, which I'll draw in blue. So this is the perpendicular bisector, right? So this is a right angle. And why do we do this? Because any point on this perpendicular bisector, let's say this random point, will be equidistant from A and A prime. So we know that P is 1 point on this line. Okay, so what about the perpendicular bisector of B prime? So this is also pretty easy to do. This is just around like this. So around this line over here. This is again a right angle. So this means that their intersection point, which is this point over here, will be around where P is. Since the intersection point P is on both the perpendicular bisector of A prime and B prime, it's equidistant from both A prime and equidistant from B prime. So this means that as long as we find the coordinates of this green dot, we're done, like we're just done. So to find the green dot, the most straightforward way we can think of is just find the equations for the 2 lines and then solve for the intersection point of the 2 lines for the perpendicular bisector. So we need to solve for the blue and red lines. So how? Well, let's just call the blue line L1. So let's just first find the slope of this. Or actually, let's just first find the slope of A prime. So what is the slope of A prime? So the slope of A prime is, well, so A is 1, 3, and A prime is 3, 3. Wait, no, A prime is 3, 1. So A is 1, 2. So this means that the slope would be y2 minus y1 over x2 minus x1. So the slope would be 2 minus 1 over 1 minus 3, which is negative 1/2. Okay, but this is a slope for this line, not for our perpendicular bisector. But we know that when two lines in the coordinate plane, or any two lines are perpendicular to each other, the slope of the other line is just the negative reciprocal of the slope of the first line. So the actual slope is gonna be the negative reciprocal. The reciprocal of this is just negative 2. So the actual slope would be 2. Okay, so the actual slope is 2. And since we know the actual slope is 2 now, we can write this in equation form and solve for the coefficient. So we know that therefore that y equals mx plus b, where m is 2, so 2x plus b. We can solve for the small b here. So how do we do so? Well, we know as long as we find a point of intersection, we can solve for that. So let's just use this point of intersection. This is like the midpoint of AA prime. So the midpoint of AA prime is 1 plus 3 over 2, which is 2, and 2 plus 1 over 2, which is 3 over 2. So it's 2, 3 over 2. So and this point is also on a perpendicular bisector. So if we plug that into the equation, we have 3 over 2 equals 2 times 2, which is 4 plus b. So b equals 3 over 2 minus 8 over 2, negative 5 over 2. So our equation is really just 2x plus b minus 5 over 2. What about the other equation for the red line? Well, the slope, so let's just first find the slope of this line here, BB prime. Well, the slope of BB prime is just, so the slope of BB prime is just y2 minus y1 over x2 minus x1. Now b is 3, 3. B prime is 4, 3. So the slope is gonna be 0. So we know that the slope is 0. And this means that the slope of this line is also 0. In fact, this is so the perpendicular bisector of B prime is a straight line, so it's supposed to be x equals something. So we just need to find the x coordinate of one of its intersections point, because the x coordinate of everything here is just consistent. So let's try to find the x coordinate of this intersection point. That is the midpoint of BB prime. So the midpoint of BB prime is going to be 3 plus 4, which is 7 divided by 2. So 7 over 2. And 7 over 2, 3. So that's one of the points on this straight line that is parallel to the y-axis. Since it's parallel to the y-axis, we don't really have to find y or anything. The equation is just going to be x equals 7 over 2. Oh, let me write that in red. X equals 7 over 2. So we just want to find the intersection of the blue and red line, which is just this green point, over here, and that's just our P. So we put these two equations into a system of equations. Then we know that x is 7 over 2, so we can plug this in. Y equals 2 times 7 over 2 minus 5 over 2 equals, the 2's cancel out, 7 minus 5 over 2. So 7 is 2 over 14. So this is 9 over 2. Okay, so y is 9 over 2. So the coordinates for P will be 7 over 2, 9 over 2. Now, P is also equal to RS. And we want the absolute value of R minus S, which is the absolute value of 7 over 2 minus 9 over 2, which is the absolute value of negative 1, so that's just 1. So our answer is E.